Welcome back. This is Chapter 2, Section 2, Find Slope and Rate of Change. Let's start off by doing a couple vocabulary words for slope. Slope is vertical change. Over horizontal change. So there's lots of ways to think about this. Delta, this little triangle, means change. So, and when you think about a graph, the vertical axis is the y and the horizontal axis is the x. So the vertical change is the change in y over the change in x. You could also think of a vertical change as rise and a horizontal change as run. Or mathematically speaking, you could say that you have two y values, so you subtract them, and then you subtract their corresponding x values to give you the slope. Parallel lines do not intersect. All right, you should know that. You just came from geometry probably. Do not intersect. If you're dealing with the slope of parallel lines, then you would say slope 1 is equivalent to slope 2. Perpendicular, they intersect at a right angle. And if you're thinking about slope m1, the perpendicular slope would be like -1 over m1. They are opposite. Let me do this in a different color. Opposite reciprocal. Opposite reciprocal. The rate of change is change in the relationship between change in quantities. So we'll say ratio between the change of two quantities. That means like units. That means miles per hour. Oh, I don't know why I spelled like that. Miles per hour. So that's the vocabulary. Let's jump into this. The slope m of a non-vertical line is the ratio of blank change to blank change. The rise, so if you look at the vocabulary word, the rise is the change in y, which is the vertical change, to horizontal change. Now, algebraically, we look at it as y2 minus y1 over x2 minus x1, which this right here is the slope, and this is the rise, and this is the run. And you can see it in the graph how it works. If you start at a point, you have a certain amount of rise and then a certain amount of run to get right back to that line. So what is the slope of the line passing through these 2 points? When you're given points like this, It probably will just be faster for you to use the slope formula. So y2 minus y1. So y2 here is 7 minus 3. And then x2 belongs with the, here, this is y2, so that means this is x2. So 7 minus 3 is 4, 6 minus 1 is 5. So the slope of the line is 4/5. You could also think of this as change. So start at 1. Well, actually, let's start at 3. Let's do it a different way now. If you want to use the formula way, I would just let the video play and don't follow along. But another way to think about this is if you start at y is 3, how far does it take you? What is the change from 3 to 7? How far do you have to go? Well, you should know that the change from 3 to 7 is 4. Then start at 1. And what is the change to get to 6? Well, 1 to 6, that's 5. So our change in our y over our change in our x is 4/5. So you don't have to use the formula. You can use the concept of change of y over change of x if you want. Okay, guided practice number 1 says, what if, in example 1, suppose the rise of the ramp is changed to 12 inches without changing the run. What is the slope of the ramp? So if you go back to example 1, you'll see that you have a ramp. It says that the rise of the ramp changed to 12, but the run stayed at 54. They want to know what the slope of the ramp is. So, slope is vertical change, or the rise, over the horizontal change, which is the run. So if we started right here, and we needed to know what the rise was, you would say that the rise is 12. And then if you needed to know what the run is, you would say 54. Now this is a correct answer, but of course you should be able to reduce it. I'm going to reduce this to 2 by 6. Let's see, divide that by 6, divide that by 2/9. For every 2 feet of rise, there's 9 feet of run. Number 3, this tells us to use the slope. Find the slope between 0,3 and 4,8. So you'll go back to this example that we did here. You can use the formula and say that y2 is 8 minus 3, 4 minus 0, that becomes 5/4. Or you can just look at this and say 3 gets bigger to 8. So 3 increases by 5. There's a 5 change. Then there's a 4 change, and you just have your answer. So either way works. Classification of lines by slope. The slope of a line indicates whether the line from left to, whether the line blank from left to right or blank from left to right. So left to right is key here. You read a book and you read sentences in a newspaper and mathematical equations from left to right. So the slope of a line indicates whether the line rises from left to right, falls from left to right, is 0, or is undefined. So this right here, if it rises, just think about the arrow. I mean, when you're reading this graph, the arrow is pointing up. So that's why you would say it rises. If it's negative, if when you read this graph left to right, you see the arrows pointing down, so it falls. Here, is there any rise? Actually, let's think about that. Let's look at rise over run for this. For this one, if we started here and ended here, we would have to go a positive rise or over a positive run, which gives us a positive slope. Here, if we went from this point to this point, you would need a negative rise over a positive, which would give you an overall negative slope. This one here, though, let's talk about this. Here, what kind of rise is there? Is there any rise? Up or down movement? There's not. So you would say 0 over a, that's a positive. 0 over any number is 0. That's why it's a 0 slope. It's horizontal. The next one, now there's an infinite number of rise. From this point, it goes up forever. But the key for this is not that it goes up forever and is an infinite rise. It's that there is no run. So we could say it's a positive rise and a 0 run. And can you divide by 0? Should say no. And therefore, you would say it's undefined. Vertical are undefined slopes. So I'm going to add a couple of extra notes in here. Please remember that up and right equals positive, down and left equals negative. Please remember that. All right, so let's do a checkpoint. Find the slope of a line passing through these points. You can do it however you want. For the most part, though, you should start by labeling them y1 or x1, y1, x2, y2, throwing them into the formula 9 minus 2, 7 minus 4. It becomes 7 over 3. Your slope is 7/3. Without graphing, tell whether the line through the points rises, falls, is horizontal or vertical. So we need to look at the slope. So let's start here. This is x1, this is y1, this is x2, this is y2. Let's start by going with the y2, 4 minus 2. And then here's x2, 1 minus negative 3. So 4 minus 2 is 2. 1 minus minus 3, that's a plus, that's 2/4. It's a positive 1/2. Positive number means it rises. Guided practice 7 and 9. 7, once again, that's asking us if it rises or falls. Here's a negative 4, 3, 2, negative 6. I'm going to label these x2, y2, and this one's x1, y1. Doesn't matter. So if you switch the points around, it shouldn't matter. The slopes will be the same. So the formula says 3 minus 6 divided by negative 4 minus 2. Well, 3 minus a minus, that's plus. So that's 9 divided by negative 4 with a negative 2, negative 6. So this result is a negative slope. So you would write false. Number 9. 3 negative 2. 5 negative 2. Let's work it out. Well, let's say this time x1, y1, x2, y2. We're going to do negative 2 minus minus 2. And then 5 minus 3. That becomes minus a minus 0 over 2. Therefore, your slope is 0. And if you look back at your list, a 0 slope is a horizontal line. All right. Parallel lines. Consider two different non-vertical lines, blah, 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 blah. The lines are parallel if and only if they have the same slope. That means this rise over run is the same as this rise over run. The numbers might be a little different, like this could be 2 over 2, and this here would be 3 over 3. Altogether, the slopes still equal 1. Perpendicular lines, if and only if their slopes are opposite, reciprocals. It means M1 equals, I guess you would say, 1 over M2, negative 1 over M2. So, or if you multiply the slopes together, they should equal negative 1. Remember though, everyone, opposite reciprocals. 2, the opposite reciprocal is negative 1/2. 2/3, the opposite reciprocal is negative 3/2. 2/5, negative 2/5, the opposite reciprocal is positive 5/2. So these slopes are all perpendicular to one another. Tell whether the lines are perpendicular, parallel, or perpendicular. Well, M1, 5 minus minus 1, 2 minus minus 3, so minus a minus. That's 6 over minus a minus 6 over 5. The next one, 1 minus minus 4, negative 3 minus 3. So this one right here ends up minus is plus, so 5 over negative 6. So what you can see is because if you multiplied 6/5 by negative 5/6, the 6's would become 1, that'd become 1. You'd end up with, I guess I could have done it here. Our negative of each other. So the lines are perpendicular. I'll use this as a symbol for perpendicular. All right, let's do it one more time. Let's find slope of line 1. That'd be 4 minus 0, 3 minus 1. We have 4/3 as our M1 slope. M2 should be 5 minus 6 over negative 2 minus minus 4 plus plus. That becomes negative 1 over 2. Are these opposite reciprocals? No. Are they the same? No. So you would say it is neither parallel nor perpendicular. Guided practice 11. This is another example of those points. Negative 2, 8. 2, negative 4. So, what's the slope of line 1? Negative 4 minus 8 over 2 minus minus 2. Negative 4 minus, that's negative 12. Negative 2 minus a minus 2. is 4, which ends up being negative 3. The second point, negative 5, 1, negative 2, 2. Let's work this out. 2 minus 1 all over negative 2 minus 5. Oh, adding this. So 2 minus 1 is 1. Negative 2 plus 5 is 3. So your slope is negative 3. And then the other one is 1/3. So you should see right away, since they are opposite reciprocals, they are perpendicular. All right, I'm just going to explain example number 13 to you. It says, in example 5, suppose the diameter of a sequoia is 248 inches. Find the rate of change in the diameter and use it to predict the diameter in 2105. So, what you're doing is you need to compare. Basically, what you need to find are 2 points. So, suppose that the diameter of the sequoia is 248 inches in 1965. All right. So, time should always be your x, and the other one is inches. So time is always x. So when you look at this, you've got 2 points. You have a year, 1965. You have inches for that year, 248. You have another year of 2005 and another inches of 251. So, change of y over change of x. Well, how many years passed from these right here? The change in y would be 3. The change in x would be, let's see here, 40 it looks like. So 3 over 40 is the rate of change. It is approximately 0.075 inches per year. That's it. So I tried to keep it short and sweet. This is what we should be working on in class. Make sure you finish the guided practices. There should only be like a handful that you still have to do. Good luck.